Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next question on the test. This is a communication kind of question, so we have to find the values of x where this function here, the graph, is going to be discontinuous, and we have to explain the type of discontinuity that's going to be found at these values. And not only do I want to talk about the type of discontinuity, so if you remember there's like infinite discontinuity, jump discontinuity, removable or point discontinuity, I also want to talk about how the x values where it's going to be discontinuous, how it fails those three conditions of continuity that we went over in the continuity section in the lecture videos, which I'm assuming you have watched. If you haven't watched those, please make sure you do, because not only do I go through the three conditions, I go through different examples as well. And if you remember the three conditions here for continuity, f of x is continuous at x equals a. If these three conditions exist, f of a exists or is defined, the limit as x approaches a of f of x also exists, and then the third condition is that both 1 and 2 are equal to each other, right? So the limit as x approaches a of f of x is equal to f of a. Okay, so any points of discontinuity that we find here, let's talk about also which of these conditions are going to fail to make it discontinuous. So starting off from the leftmost x value, negative infinity, and then we'll go to the right. So if we keep going on this graph, basically whenever I have to take my pen off the paper to graph, that's when there's going to be discontinuity. So notice here, this is going to be the first one, right? At this x value of -1, notice that here there is going to be a vertical asymptote, or we could also say it's an infinite discontinuity. And because it's a vertical asymptote here, notice that there is no f of -1, right? F of -1 here does not exist. Now notice that the limit as x approaches -1 from both sides, they're going towards negative, or sorry, not negative, what am I saying? Towards positive infinity, right? The y values are going towards positive infinity from the left side, from the right side, but notice that f of a does not exist, right? The function is undefined at that x value of -1. So here for this x value of -1, we could say that condition 1 fails, like that. Okay, and let's keep going on the graph. So if we keep going, notice that once we get to this x value of 0 right here, I have to take my pen off the paper to continue the graph over here, right? And so notice that at this x value of 0, there is a jump discontinuity, right? We're going from a y value of 1 to a y value of -1. So we would say that this here is going to be a jump discontinuity. And now which of these conditions here is going to fail? Well, notice that f of 0 does exist, right? Because this is a solid dot. So f of 0 is equal to +1. So condition 1 passes. But notice the limit as x approaches 0 of f of x does not exist, right? So condition 2 fails. Now, why does it not exist? Because notice as we approach this x value 0 from both sides, we're approaching different y values. As we approach it from the left side or from the negative side, we're approaching a y value of 1. As we approach it from the right side, this x value 0, we're approaching a y value of -1. And so whenever you're approaching two different y values from each side of the x value you're looking at, the overall limit at that x value does not exist, right? So condition 2 fails in that regard. Now, if we keep going from there, notice our next discontinuity is going to be at this x value of 2, right? Notice that there's a hole there, so I have to take the pen off the paper in order to continue the function. So at an x value of 2, right over here, we have a hole, and that's also called a removable discontinuity or a point discontinuity. Some textbooks might say a point discontinuity. Right? Now, which of these conditions is going to fail? Notice that the first one is going to fail because f of 2 does not exist. Right? There's no solid dot here on this x value of 2 anywhere. Right? So there's just a hole here. So condition 1 fails. We don't even have to go into the other ones. The limit does exist, right? The limit, notice the limit as x approaches 2 of f of x. Notice that we're approaching that same y value from both sides of -1. Right? So the limit does exist. However, notice that f of 2 is not defined anywhere. There's no solid dot. And so condition 1 fails for this x value of 2. And then if we move on, notice the last one, where's there going to be a discontinuity? Here at this x value of 4. And notice that that's a hole as well, right? So that's going to be a removable discontinuity. Now, which condition is going to fail here? Because notice that f of 4 does exist, right? Notice that f of 4, we have a solid dot here. That's equal to 2. Okay, so that condition passes. Does the limit as x approaches 4 exist? Yes, it does, right? The limit as x approaches 4 of f of x, what y value are we approaching from both sides? We're approaching that y value of -1, right? So condition 2 passes. Condition 1 passes, condition 2 passes, but notice that in this case, condition 3 is going to fail, right? Because notice that f of 4, it equals 2, and the limit as x approaches 4 of f of x is equal to -1, and notice that those two are not equal, right? And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.